If you were not in class or if you're just struggling with these sequence word problems, I wanted to do a quick video to kind of help you out. On reading these, the first thing you're going to have to decide on all of them is whether your situation is an arithmetic situation or a geometric. And just kind of remember that arithmetic is always involving addition and subtraction. So as you read the problem, you notice that you're consistently adding or subtracting something. Geometric is consistently multiplying or dividing by a same amount. And on geometric, you're gonna figure out how to write it as a multiplication problem, okay? The division isn't terrible, but you very rarely see formulas that way. Now, once you've decided which version you're in, you have two different versions within that category that you can use. So the first thing I want us to kind of keep track of is that arithmetic, your formula is going to have addition or possibly subtraction if it's a negative. Your geometric is going to have multiplication in there, which I typically will use a dot so it doesn't look like an X, or you could use parentheses. Remember that you have two options. You can either drop back to the zero term, the y-intercept, or you can go ahead and just start with the first term. The only difference between these, you're still repeatedly adding the common difference. It's just, if you do the zero term, you're going to use a plain n. If you head start to the first term, it's going to be an n minus 1. So if you decide a problem is addition, subtraction, then you just have to decide when reading the problem, well, did they give me the zero term before anything has happened? Or is the number they're giving me the first value in my pattern, like maybe after the first month or the first row of chairs or something like that, okay? Geometric, the same thing. You have the same choice to either start with a sub 0 or a sub 1. Are they giving me the y-intercept value or the first term? And in this one, remember, we call it an R instead of a D because it is a common ratio, not a common difference. And then geometric is where you have your exponent. It's the same basic pattern. If you use the y-intercept, you're just going to put a plain n. If you skip ahead to the first term, then you're going to put n minus 1. But it's still, basically, it's just, well, do I have an addition linear setup or do I have a multiplication exponential setup? Okay, so I just wanted to have that out there as a reminder. So when you start reading these problems, I'm going to look at the back number 1 because people struggle with it. The CIA estimates that the world population is growing at a rate of 1.167% each year. The world population for 2007 was about 6.6 billion. Well, the fact that this is a percentage tells me that this is a geometric situation because when you were in elementary school, you learned that you multiply by percentages. Okay, if you're a little shaky on that, we need to do some work. Well, the problem is you can't multiply by a percent as is. You have to convert it to a decimal. So remember, again, like 5th, 6th grade review, if I back that decimal up 2 spots, it gives me 0.01167. That's the number we're actually using instead of the percentage, all right? So we're going to multiply that. But we run into this issue where it tells me in part A the common ratio is not 0.01167. Well, that's what we just decided it was if we take a percentage and adjust it to a decimal. Now let's look at why this is happening. A couple of people in class realize, well, no, if you're multiplying by that every time, that's actually going to create a decay situation. It's going to make my numbers get smaller each time to multiply by that decimal. And this problem very clearly states that it is growing. So this is a growth. So I know I need a number greater than 1. All right. So here's how we have to kind of visualize this. The 1.167% is not telling me from year to year. It's telling me, okay, so I start out with 6.6 million people. This is like my little bar graph for the number of people there are in the world, okay? In the next year, I'm going to add, so I'm going to have a higher population. And I've taken my 6.6 million and I've added whatever 1.167% is to it. So when I go to year 2, I'm not only talking about that little 1% sliver that we added on. In year 2, I actually want this entire distance, okay, the entire amount. So not just the additional 1%, but also all the original people I had there too. So really, if you think about it, okay, this was 100% of my people last year. Well, I want all 100% of my people from the year before and 1% more. So this is really like 101.167%. Okay, it's not just the 1.167%. It's not just the 1%. It's 101%. So you say, hey, I want 100 of the people, 100% of the people I had, and 1% extra. Okay, and then the next year I'll have 101% now of the new group. Okay, so that's why they say the common ratio is not 0.1167. It's actually, okay, so if I'm going to say I really want 101.167, but it's a percentage, so I'm going to adjust that decimal. That means that my ratio is actually 1.01167. Okay, I have to add 100% onto the growth because I want 100% of my people plus the growth. I hope that makes sense. You can almost think of it as like an R0 situation. You have to add 1 to it because this is just telling you about the new people being born or the new additions to the population. The 100, the extra 1, is going to include the original. So the equation would be, all right, A sub n equals, I'm starting with 6.6 billion. I'm multiplying by 1.01167 for that 101% growth. And then I'm raising to, you got to kind of ask yourself, well, is this the first year that I'm using information or is it the 0 year? We're going to go ahead and call that the first year. So that would mean my formula would need an n minus 1. Now, part B gets really tricky because it says, what will the estimated world population be in 2017? A lot of kids wanted to just plug in a 17 right there. But if I'm thinking about it, so 2007 was a 1. Well, 2017 isn't going to be 17 past that. So here's how we kind of look at this. We say, okay, well, A1 was 2007. I'm going to follow my pattern. That was 6.6 million. So I'm going to say, okay, well, that would put A2 at 08, right? 2008. A3 would be 09. A4 would be 2010. A5 would be 2011. And then I'm just going to keep going. 12, 13, 14, 15, 16, 17 is where I'm wanting to get out to. I realize, yeah, y'all can see what I'm writing. 16, 17. Well, if I actually count what term that is, if 2007 is term 1, I'm going to keep going all the way out. A6, the 7th term, the 8th term, the 9th term, the 10th term. That would actually put 2017 as the 11th term. So let me zoom out so you can kind of see everything there. So if the first term is 2007, I'm just going year, year, year. Every year, we're going to be multiplying by my ratio all the way out. So that actually puts me in the 11th term here. So I'm going to take my formula and I'm going to say, okay, I've got to figure out A sub 11. That's weird because it doesn't really match the year. But again, if you count out what term that is, that's how we get there. So I'm going to go 6.6 times 1.01167 raised to the 11 minus 1. Okay, that's what my formula is telling me to do. So if I just really quick say 6.6 times 1.01167 raised to the 11 minus 1, or if you're feeling really advanced to do just the teeniest amount of work, you could just go ahead and put a 10 up there. You end up with an answer of 7.41195. I'm going to go ahead and just round that to 7.4 billion people. Okay, so it's kind of tricky there figuring out that 2017 value. Because percentages are tricky, let's look at number 3. So if I look at this situation, Arnold has a bank account with a beginning balance of $5,000. Okay, he spends 1/5. He spends 1/5 of the balance each month. How much money will be in the account after 6 months? I think that spending 1/5 is basically spending 20%. Okay, that's a simple little number conversion. So 0.2, that makes it geometric. And then I'm going to look at, okay, here's where it gets tricky. They're giving me information about how much he's spending. The question is asking how much will be in the account. So essentially, how much is he keeping? And so the easiest way to write this formula is to say, okay, well, he's keeping, if he's spending 0.2, that means he's keeping 80% of it, okay? So that would be your R value on this problem. All right, you got to kind of think about what is the question actually asking in terms of. And then from there, you've got to figure out the rest of the formula and whether it's not A0 or A1. So good luck with that, and then estimate where you'd be after 6 months. Okay? All right, good luck.